Hey everybody, today I want to talk to you about how to solve inequalities involving absolute value functions. This is the type of question that this concept will pop up in, something where you have these weird bars and then an inequality involved in the equation that you're solving. And you're looking for a description of x that will describe this inequality. There's a lot of ideas to unpack here, so I'm going to kind of go slowly from the ground up, and then at the end of the video we'll solve this initial question, which looks complicated now. So to start off, what is the absolute value function? So the absolute value function is just a really simple little rule that contains powerful ideas. So here's what it is. If you give me an x that's greater than 0, I'm going to give you x back. If you give me an x that's less than 0, I'm going to give you negative x back. And if x is equal to 0, I'll just give you 0 back. So basically, what would the absolute value of negative 6 be? Well, it's negative 6 is less than 0, so I'm going to give you negative 6 back, which is just 6. If you gave me the absolute value of 5, well, that's above 0, so I'm just going to give you 5 back. And the absolute value of 0 is always 0. So you kind of have an idea for what this function is doing. It kind of takes everything and gives you the positive value of it. Is a basic understanding of what's going on. A better understanding of it would be that the absolute value function describes something's distance from 0. What do I mean by that? Well, I'm going to probably take a bunch of you back a few years to the number line. The number line, it's where all the numbers live, all of our favorite numbers, including 4 and negative 4. So the reason I picked negative 4 and 4 is because I'm going to give you this equation of the absolute value of x being equal to 4. How would you solve this? What values of x make this statement true? Okay, you don't know what x is. X could be literally anything. So if x is greater than 0, then x would be equal to 4, right? Because you just get the normal number back. So we know that x could be equal to 4. But what if x was less than 0? Then you would have to give me negative x back. So I know negative x could be equal to 4 too. So it could be either of these things. And if you solve the right-hand equation, you can see that x is equal to 4 or x is equal to negative 4. Right? It could be either of these. The important thing to notice is that what it's doing is kind of telling you how far away that number is from 0. How far away from 0 is x? It's 4 away, so it could be negative 4 or 4. And when we introduce inequalities, let's think about how does this interact with inequalities, question mark. So instead of the absolute value of x being equal to 4, now let's think about what does this look like? The absolute value of x being less than or equal to 4. Well, let's pull out our number line and put our 4's down, because we know that 4 is going to be involved. So the absolute value of x would be less than or equal to 4. So if x was greater than 0, then you just give me the normal x back. But what if x was less than 0? So we know that this could also be true. Negative x being less than or equal to 4. So it's going to be all the numbers in between here that have a distance of 4 or less. So it could be everything in here. It could be because it's in between two numbers on the number line, you say and. So x is less than or equal to 4, and you've got to flip the sign. here's what I did. I just multiplied by -1, so you have to flip your inequality. So using the definition of our absolute value function, I knew that both of these had to be true. And looking at my number line, I saw, okay, x is going to be somewhere in here, so I know they both have to be true at the same time because -4 is less than 4. So then in general, we would say the set of x that satisfies this inequality would be x such that x is greater than -4 or x is less than 4. It's everything that has a distance of 4 or less. So this is getting a little bit more abstract, but I just constantly keep in your mind this idea of distance and that x could be anything, so you have to check for all possibilities. So now that I just said that this is a little abstract, I'm going to make it even more abstract. Let's make this a little more difficult. Now what I'm going to do is put something else in the parentheses. Let's say 3. The absolute value of less than or equal, the absolute value of x plus 3 has to be less than or equal to 4. I know it must be kind of annoying me to keep drawing these number lines, but conceptually I want you to think of distance. So whatever this is going to be, we don't know what it's going to be, we're going to handle that in a bit. It's going to look like this on the number line. Whatever's in here has to have a distance of less than or equal to 4. So, what if what's in here is greater than 0? Then you just get the positive value of that whole quantity back. But what if what's in here is less than or equal, is less than 0? Well, then you have to check the negative of the entire quantity. Not just the x, the entire quantity. And because what we're looking on the number line is a set interval where 4 is greater than -4, we know that it's going to be an and. It's going to be all the x's in here such that whatever this is going to be less than 4 and greater than -4. So now we'll do the actual solving bit. And this is the easiest part of these things. So I'll distribute the -1, and then I'm going to move my 3 over, and I'm going to flip my sign. Right at the end. Don't forget to flip your signs. That messes a lot of people up, and it's right at the end of your work, so it's really annoying when it goes wrong. So then what we would say is, what solves this inequality? It's x such that x is less than 1 and it's greater than -7. So this would be the final answer to this inequality. So when there's a less than or equal to sign, we write and, right? Because what I said before, it has to do with the number line, and x is in between two numbers, so it has to be, both these inequalities have to be true at the same time. The next example I'm going to give you is going to be with a greater than symbol, and we'll see what happens with that. So now another example with a, let me make sure I write this greater than inequality. Alright, so we just did this one, this inequality with less than or equal to sign. Now I want to talk to you about a little more daunting of an idea, a greater than sign. So I'm going to bust out my number line and put my 5s on it, because I know 5 is on this side of the equation. So whatever's in here, it has to be greater than 5. It's got to be more than 5 away from 0. So it's going to be all the stuff over here and all the stuff over here. But we can't use the word and, because whatever we find as our answer, x, it's not going to be less than -5 and greater than 5. I do that on almost every video. It's not going to be over here and over there at the same time. It's got to be or. Whatever your x is, it's got to be on this side or that side. So when we do our negative and positive thing, we write or instead. Take the negative of the entire quantity, remember, but the key thing here is the or, right? Because we're describing something that's going to be over here or over there, not in between, so it's not and. So I'll do a little bit of solving here. I moved over my 2 to get 7, and I'm going to rewrite this greater than sign, because that's not a greater than sign, it's kind of a C. I'll divide this, so or. This one's going to be a little bit more work. So we distribute the negative, move over the -2, and once again we got to flip our signs. -3, -1, okay. So here's what we're seeing. X is greater than 7/3 or X is less than -1. And just in case you guys are having a disconnect between the 5s and the answer that we're getting, this weird fraction and negative, this, pencil, pen thing, stylus. This number line I drew, describe, is just working with the absolute value inequality. So whatever's in here, it's going to look like this on the number line. But when we actually go to find the x's that make this true, they're going to have different values because of the coefficient and the -2. The important thing to understand here, but by the way, this is, we've solved everything. This is how you would do a question like this. It's not that difficult. The things they keep track of are the ors and ands, and really thinking about what the absolute value function is describing and why it describes something's distance from 0. When you're working through a question like this, the first thing I want you to do, if you're having trouble, is draw yourself a number line and think about what the equation is trying to express and whether or not you should be using ors or ands, and then solving from there. This is a little bit of a difficult concept, so do some practice questions, and I'm sure you guys will get it after a while. I hope this video helped, and have a great day.